Okay, welcome. In this short lecture video, we're going to discuss about how to solve system of differential equations using knowledge on a Laplace transform and inverse Laplace transform. So this is a problem. So you have to solve the initial value problem, y prime of x, y prime of t plus 2y of t minus 4x of t equals to minus 4t minus 2. And then x prime of t minus 2y of t equals to 4t, subject to the initial conditions. X at 0 is 4, and then y at 0 is minus 5. So this is how we solve this problem. So solution. So the first thing, let capital X of t, x of s, not capital, let capital S of x of s to be the Laplace transform of x of t. So x of s to be the Laplace transform of x of t. And then capital Y of t, y of s to be the Laplace transform of y. And then y of s to be the Laplace transform of y. And then we know that Laplace transform of the derivative of x with this notation, Laplace transform of x prime, the same as s, capital X of s minus x at 0. So which we can say will be given by s, capital X of s minus x at 0 is 4. And Laplace transform of y prime is s y of s minus y at 0. So which will be s capital Y of s, and then this is minus 5, so plus 5. So once we have these ones, then we using, let me call this one star. So supply star in the original equation, original system. So this system here. So remember, so where there's x prime, we put this. Y prime, we put this. X, we put this one here, and then this one, this for y. So i.e. the same thing as saying apply Laplace on the system, i.e. this is what I mean. So we'll have Laplace transform of x prime, then minus Laplace transform of 2y, and then minus Laplace of 4x, and then equals to so let's replace step by step from the first equation. So I'll have Laplace transform of x prime minus 2 Laplace transform of y, and then equals Laplace transform of t. So I'm doing this one because we know that Laplace operator is a linear operator. That's why I'm doing this. And then the other one will be Laplace of y prime plus 2 Laplace of y minus 4 Laplace of x equals to minus 4 Laplace of t minus 2 Laplace of 1. So this is just applying Laplace on each of the terms in the system given in the equation. So that now we'll get this one will replace by what we have already obtained here as sx minus 4. So we'll have s x of s minus 4 minus 2y of s equals to, so Laplace transform of t is 1 over s squared, so we'll have 4 over s squared. And then Laplace transform of this one here is given by s y of s plus 5. I've gotten it from this. And then plus 2 y of s minus 4 x of s equals to minus 4 over s squared, and then minus 2 over s. So this can as well, so if we call this one 1, call this one 2, so then 1 and 2 becomes respectively s x of s minus 2 y of s equals to 4 over s squared. This one will be plus, which you can put under 1 HCM to have 4 plus 4s squared. So this now, let's call this new equation, let's call it 3. This 3 is from 1, and this other one will have s plus 2, and then y of s minus 4x of s equals to minus 4 over s squared minus 2 over s minus 5. So you can say over 1, LCM is s squared minus 4 minus 2s minus 5s squared. So which then if you call this one 4, then these two systems can be written as s x of s minus 2 y of s equals to 4 plus 4s squared over s squared. And then this I can write it as minus 4x of s plus s plus 2 y of s equals to, so this I can actually factor out negative and then say 5s squared plus 2s plus 4 and then over s squared. So remember, this negative is affecting everything here. So therefore, let's call this one 5. Let's call this one 6. So that's the system that we have. Now, let's multiply. So we solve by elimination. Let's multiply this one, this equation, let's multiply it by s plus 2, and let's multiply this one by 2. So that we'll have, so we want to eliminate capital Y of S into these two systems. So we have S into S plus 2, and then capital X of S minus 2 into S plus 2, capital Y of S equals to S plus 2 into 4 plus 4S squared over S squared. And then this other one will be minus 8x of S plus 2 into S plus 2 capital Y of S equals to minus. So this two is multiplying everything here. So 10S squared plus 4S plus 8 over S squared. So now with these two, we simply add so that we eliminate Y capital Y. So when we add, we'll have S into S plus 2 minus 8, and then capital X of S equals 2. So I can open this one and get 4S power 3, and then let me just write it the way it is. Then let's just open. So then plus 4S, so 4S power 3 plus 4S, and then plus 8 plus 8 4S squared, 8S squared over S squared minus 10S squared plus 4S plus 8 divided by S squared. So S into S plus 2 minus 8, capital X of S equals to, so I have 4S cubed plus 4S plus 8 plus 8S squared minus 10S squared. Remember, this minus affects everything here, so minus 4S minus 8. So that now from this, I have this and this cancels out. And then I'll have this and this cancels out. So that I'll have S squared plus 2S minus 8 capital X of S equals to 4S cubed minus 2S squared over S squared. And you see that you can factor out S squared, and then you have 4S minus 1 minus 2 minus 2 divided by S squared, and then this and this cancels out. So just we have 4S minus 2, so that we have S squared plus 2S minus 8 capital X of S equals to 4S minus 2. And then X of S, we divide by this, so we'll have 4S minus 2, S squared plus 2S minus 8. These are quadratic expressions, product. is minus 8, sum is 2. Numbers will give you minus 2 and 4, so that we have x squared minus 2s plus 4s minus 8. So common here is s into s minus 2 plus 4 into s minus 2. So s plus 4 s minus 2 becomes the factorization of this. So capital X of s equals to 4s minus 2 over s plus 4 and then s minus 2. So then we use partial fractions. So this is the same as a over s plus 4 plus b over s minus 2. So that capital X of s will be 4s minus 2 s plus 4 into s minus 2 equals to s plus 4 s minus 2 a into s minus 2 plus b into s plus 4. So which tells us that 4s minus 2 is equivalent to a s minus 2 plus b s plus 4. So when we set s to be 2, then 2 by 4 will be 8 minus 2, 6 equals to 6b. So this tells you that b equals to 1. When you set s to be minus 4, then minus 4 by 4 minus 16 minus 2 minus 18 equals to minus 4 minus 6a. So it tells you that a equals to 3. So telling you that capital S of x equals to a, which is 3 over s plus 4 plus b, which is 1 over s minus 1. So therefore, we apply inverse Laplace transform on this one here, so that we have inverse Laplace of capital X of s equals to inverse Laplace transform of 3 over s plus 4 plus minus 1 over s minus 1. And this Laplace inverse of this one is small x of t, which will be this one. You can factor out 3, linearity property of the inverse Laplace transform, so that we get 3 1 over s plus this one is a standard one, which is just be given by e raised power. So this, remember this is 2. This is 2, not 1. So this is 2. So that will give us e raised power 2t, and therefore x of t will be 3. This one is also a standard one, e raised power minus 4t plus e raised power 2t. So this is the solution of the function x of t. Now, so since from equation 1 in the system, since from first equation in the system, in the original problem, we have y of t equals to a half x prime of t minus 2t, because remember that equation was x prime of t minus 2y of t and then equals to 4t. So when you make y of t the subject, then this is what you get. So therefore, if maybe I will call this equation alpha. So from alpha, x prime of t, just differentiating this one, we have minus 12 e raised power minus 4t, and then this will give us 2 e raised power 2t. So therefore, I simply replace this derivative at this point to get the function y. So therefore, y of t will be a half into minus 12 e raised power minus 4t plus 2 e raised power 2t plus, not plus, minus this one here, 2t. So minus 2t. When you simplify this one, you'll get y of t equals to minus 6 e raised power minus 4t plus e raised power 2t and then minus 2t. So therefore, this is the solution for the other function y. So this is the solution for the y function, and then this is the solution for the x function. So that's how we're supposed to solve that problem. Thank you.